Hello everyone. Now I'm going to make another demo for an X-apps using a reinforcement learning to change, let's say, the massive MIMO order. So this program is going to implement a reinforcement learning and based approach for dynamically optimize the massive MIMO configuration in a simulated cellular networks. And it's going to, let's say, continuously monitor real-time data from user equipments and microcells and retrieving the key performance indicators such as SINR, user equipment throughputs, and also number of the active user equipments using, let's say, DeepQN, DQN agents to make some intelligent decisions to adjust massive MIMO antenna configuration. Let's dive into this is and also this is tested through the TeraVM RSG. It's a VIV rig tester. That's and This is Vahid Kutarak. I'm a research fellow at the University of York, working for the project entitled Reach, and leading the massive MIMO part and designing R apps and X apps for adjusting massive MIMO configurations. At the first stage, let's take a look at so, see, the simulation scenarios configurations. This is cell profile that's going to use 3 cells and 5 GNU radio, let's say G node Bs, and the frequency bands it would be 100. It would be the 100 megahertz bandwidth here with the numerology 1, and also there would be the other configuration that's now I'm not going to explain all here. We and also about the user equipments, it's going to have a near, let's say, saturation of a cell, number of 30 user equipments for each cell. This is service level agreements and also QoS. And then now I'm going to, this is the live shot from the previous simulation, so I'm going to run this test and then back to this and then at the same time running or X apps. So now this is our X apps that's running. Let's take a look at the figures and then explain what's going on here. So we can see here that these are the antenna masks, and we have 4 or 5 stages here from 64 to 32 to 16 to 8 and to 4. Let's say 40 transmitter and 44R, 88R, 16T, 16R, 32T, 32R, and 6040, 64R. Massive MIMO orders, and it's going to be changed as a function of the cell traffic loads. And as you can see here, the state now it changes here in the let's say here, showing that what's going on here. These are the figures, the dynamic figures that is generated in X apps, and this is a power saving percentage. And these are the scenario that has been divided to different time period, and for each period it's going to have an average power, and then the average based on this average, and then the highest value that it says power value that's corresponding to 6040-64R, the power percentage will be computed, as we can see. And now let's dive into our simulation. And as we can see here, these are different states, and now we are in the state of the 88R. It jumped to lower part, as we can see here, and it's going to be updated. So this means that the cell load was low, and we make a decision to decrease the massive MIMO order. And this is these cells. And here the latest update in or as we can see, this is a half of antenna mask. It's the 3230R. It jumped to here from the lowest part, and it's done by that's reinforcement learnings agents. Then that has been defined the rewards functions, and we are going to here through this method of reinforcement learning, we jump to a appropriate order of the massive MIMO. So these KPIs through the machine learning methods are let's say go through a machine learning box process, and then after that the optimized and the best massive MIMO configuration order will be let's say finalized, and as a result we can see here now we are again in the 32T 32R state, and this is around 23% of the power saving. So and at this stage we can see that it's in the 32T 32R order, and still it should be same because nothing has been changed, the cell load. Okay, we can see here that now it's 16. It's going to be jumped down, expected. And as we can see, the cell throughput jumped down, and it's in comparison with the other one is a bit low because this we have considered our cell full. And here at the another stage, we can see that it jumped to the 88R. It's a lowest order. Again, it jumped up, as we can see, is a half antenna mask order. It's a half antenna, half part of the antenna element are activated. Again, it's went to the 1640 16R, and it's finalized here. The simulation was finished here. So I'm going to show you the finalized result of this simulation. We have this is the number of the runs. You have the 22 runs here in this simulation, and as we can see, and we can expect that it's the highest. This blue line is expected when we start the simulation and then running our X apps. That's based on the reinforcement learning. And these are the power that has been, let's say, consumed, and the lowest one is the 8, and the other one is the 32 T32R. And based on the changing in the cell loads, reinforcement learnings could predict the best massive MIMO order by fetching the KPIs through E2 interface, and we can see that our X app could save around, here let me show you, yeah, 25 percentage of the energy consumption. So we saved 25% of yeah, energy consumption, as we can see that consume power percentage comparing with power saving percentage. Thank you for your attention, and I hope that you enjoy this simulation. Thank you.